All right, welcome to this session where, you as a hacker, as a developer, if you want to enter like Polkadot ecosystem and try to understand what to develop, I'm sure you already have plenty of questions. So this slide deck and this presentation serves like the knowledge map. If you have access to this, I'm sure in the next 1 week, you will be able to deliver something. Okay, so let's get started with that idea. And if you want to download the slide deck, the QR code is right there. So a little bit of introduction about myself. So I'm more of a researcher than a developer. Of course, I've developed stuff. So I have a PhD in computer vision, which is like an AI subject. I had to do something on my mobile phone, get the readings from the inertial sensors, compensate for the handshake movement, and stabilize the video. So that was my first project. But to give you context, so my development experience goes into creating proof of concepts, just the way you're doing it right now in this hackathon. So I have a bit of like teaching experience, and what I try to do is bring the signal to noise ratio a little bit high. I try to, whenever I give a presentation, I try to bring the knowledge that is suitable for the audience. And that's what I try to do today as well. I hope it's useful. So someone asked like why Polkadot right earlier. So we are a happening place. Like it's not like the Polkadot is dead or like whatever meme that we had last year. So we have like 45 chains that are actually producing blocks right this moment. Plenty of accounts, and of which like we have about 170K active accounts across the whole ecosystem. And these are the stats from January, so not so long ago. And again, like TPS metric, many chains like talk about it. So we actually did a stress test, in December, right? Yeah. So we called it like spamming campaign. We let the community take part in it. We gave them wallet accounts, which could like spam the network with like transactions, right? So and then we were able to establish more than 100K transactions per second. So this is to just, the TPS in itself doesn't speak much. Of course, you have to be able to build applications to make use of that TPS, and that's where we are today here. So the other thing I want to highlight is, so Polkadot is also not only technologically advanced stack, which I'll convince you in this like 40 minutes or 30 minutes, how much ever it takes to finish this presentation. The other thing I want to show is it's also built for accessibility reasons. I heard a lot of like UX people here. Improve the accessibility of the applications, but I'm talking about the accessibility in like multiple facets. So to transfer like a stable coin, like $1, the fee is like below a cent. Okay, so this makes Web3 accessible to countries like India, where I'm from, or so and it is able to get this fee to such a low value, not out of like subsidy, but it is out of the technical design like Polkadot implemented. And the network has been stress tested like multiple times. If you are into this space like for a couple of years, you would have heard about inscriptions, which broke a couple of like major networks out there. And then Polkadot didn't even like flinch. So the fee adjustment algorithm was also, taking all that transaction volume, and still like we were able to maintain that low fee for the transactions. And yes, like DeFi has a lot of money right now. If you're a Solidity smart contract developer, your life is good. You're getting paid. But yes, so there's more you can do with blockchains than just DeFi, right? So there's plenty of other use cases that will come into like limelight over the next few years. And that's where you would want to like watch out Polkadot, because we already are facilitating state of the art, like, tech for applications like gaming with like very high volume requirements. So for instance, the official NFL app as well as like FIFA app behind the scenes is being powered by Polkadot technology stack. For all the millions of NFT volume that the user is not even like aware of, it's being taken care by Polkadot. And also like social media, like there's a lot of hype around. So what is Web3 at the end of the day? It should bring the control back to the user, right? So that was the promise of Web3, and social media is like plays a huge part in it. So we have a parachain called Frequency, which is trying to do something similar. So if you heard of the TikTok ban in the USA, it's also very relevant. So that Project Liberty that sort of launched Frequency is trying to buy like TikTok, like the US version of it, and they are confident that Polkadot technology stack will be able to handle the 100 million users that TikTok has. So I'm just telling you that people are using Polkadot, but not at the smart contract level that most people are familiar with. So people are actually counting on the Polkadot stack to think bigger and implement like bigger things. And I want you to keep that in your mind as well when you're thinking of ideas other than this hackathon. So Polkadot is able to do that because it offers a very flexible way of accessing what's called block space. So in Web3, in blockchain, you want to be able to secure a transaction. So if I send you some tokens, like nobody should refute or say, hey, you didn't send him the tokens, right? So basically, that level of security is provided by multiple blockchains out there. And Polkadot actually makes it very flexible to access that level of security. So you can actually get it 24/7. Every 6 seconds, it produces a new block, and then you're able to secure it that way. Or you can do it on demand as well. So there are a few applications which might want to maintain their own private blockchain ledger, but only update it once a day. Every 24 hours, you'd want to add entries to your ledger. So this also improves the efficiency. There are plenty of ghost chains out there which just keep producing empty blocks. So Polkadot offers a solution to them. Hey, if you're selling land and you're like a government related like application, just consolidate everything end of the day and then post it. And you don't have to post it on a public ledger. You can also put it on your private ledger. And we go even a bit further. So this feature will get released sometime in Q2, I believe. So like the regular cloud, so Polkadot is like the Web3 cloud. That's what we're going for. If you need additional transaction volume or throughput, we are able to give it to you through elastic scaling. So the example I have here is something that broke like Ethereum network, like back in the day if you followed it. So CryptoKitties, so when the volume was really high, the network was so congested, it gave like a bad experience to the users. So in Polkadot, you won't see that problem. So if you have million NFTs to mint, that is covered right there. And yeah, so the biggest selling point for Polkadot is the shared security with interoperability, right? So right now in Ethereum ecosystem, you're seeing plenty of rollups, each coming up with its own stack, its own like sequencers, its own like tokenomics or whatever, which is okay. But there is no interoperability between those rollups. At the end, they're anchoring their transactions in Ethereum. But if one rollup wants to talk to the other, there is no like framework for it. If you look at like the Ethereum developer channel discussions like over the past 2 months, they actually want to, get inspired from like what Polkadot built over like last 3 years. So we already have, I told you like 45 parachains, so they are all talking to each other. Over 1 million XCM cross consensus messaging, messages have been sent between each other. So yes, so there is activity, there is interoperability that is live on Polkadot. And we go a little bit even further. So we are also so we don't want multi-sig bridges. We don't want all those hacks where, people lose a lot of money. So what we're doing is build trustless bridges. So the way this works is Polkadot will run Ethereum's light client on-chain. So basically, Polkadot validators have an understanding of which transaction is final on Ethereum. And on the Ethereum side, there is a smart contract that understands what is final on Polkadot. So there's absolutely no middleman here. You're able to, if you make a transaction on Polkadot, Ethereum knows it. And if there is a transaction happening on Ethereum, Polkadot knows it. And the reason we're able to have bridges like this is, again, the Polkadot's technology stack, which offers a lot of flexibility. And if you're interested in this and some kind of DeFi primitives around Ethereum Polkadot, feel free to reach out to me end of this presentation. So I spoke a little bit about Polkadot technology stack. So what's so special about it, right? So this is our gift as well as our biggest curse, because Rust, WebAssembly, we're like the minority. The majority here are Solidity smart contract developers in Web3 space. So most of the talent is there. And then having learning like Rust also comes with so there's an entry barrier. So there's a learning curve. And Polkadot makes it even harder for the Rust developer, right? So you learn Rust, and then you have to understand what Polkadot SDK is, how you're using Rust and to build all these applications. So not easy. Only people who really, really want to push the technology stack to the next level have been around and been able to build blockchains and applications with it. So the reason I say it is a gift is because, again, Rust is such a memory safe, efficient language. Because blockchains are so redundant, they have to run on so many nodes. It makes sense for you to write your application using Rust, and then it brings a lot of cost efficiency, which is bringing the overall cost down, and that's what gives you sub-cent transfer fee for stable coins. If you look at the whole pipeline of it. So if you look at Polkadot's parachains, we are starting to call them rollups these days. So basically what happens is every individual parachain, it's its own chain. So you can see Asset Hub has 7 million blocks, Collectives has 5 million blocks. So all of these are individual rollups that are running and being secured by Polkadot. So and the design of it is also something that I want to show you. I mean, people can say, hey, it's being secured, but how is it being secured, right? So if you see, every individual parachain is assigned with a validator group. So these validators belong to Polkadot, and they get shuffled every minute or so. So that shuffling is sort of random. So if you have to target Asset Hub right now, this moment, you don't know which 5 validators are going to be assigned to it. So the idea is that you have to blanket attack all of the Polkadot validator set to be able to cripple that one chain. So that's how Polkadot sort of shares its security across all the chains. And then Polkadot not only has these chains, but it also uses them to spread out its functionality. So it has Asset Hub for managing the assets, Collectives for managing DAOs, Bridge Hub for those, the trustless bridges that I've talked about earlier. So People Chain, this is going to be a big thing later on this year. So I don't know how many of you are familiar with it. There's something called as Polkadot citizenship. So it's possible to have some form of proof of personhood. It's still in the early stages. So once it's released, I would know that too. And finally, core time, it gives you the flexibility of block space allocation I talked about earlier. And yes, so how does Polkadot achieve this multi-chain sharding? So the way it works is, so let's say you have to upgrade Ethereum node or Ethereum network. So you have to coordinate it offline, tell all the Ethereum operators, hey, here is the new software, node software, you have to replace it and run the new software. So in Polkadot, we do it a little bit differently. So you can think of Polkadot node as a gaming console, and then the core logic of blockchain as this gaming cartridge. So if Polkadot were to upgrade to the new runtime, it would just swap that cartridge to a new one, right? So, and also these Polkadot validators who are securing, like let's say Asset Hub right now, they're going to plug in the cartridge of Asset Hub core logic and then run those transactions as well. So that's the way we are using the same network infrastructure to sort of do validation across like so many different chains. Okay, so Ethereum doesn't have it. Ethereum was never built for this roll-up architecture to thrive on it. But Polkadot from ground up used this sort of like design to ensure, the same network infrastructure can scale to multiple chains, more than 100. And this is where I'd like to show something live, because this will give you an understanding of what Polkadot ecosystem is and how you interact with the applications there. So let me go to Polkadot.js first. Later you'll see I'll discourage you from using this library. But for now, let me use something that I am familiar with for now. Okay. All right. So if we look at this, what you're seeing here is the Network Explorer. So you can see Polkadot is producing a block every 6 seconds. So there are a bunch of events that are being recorded. So currently someone is sending someone else some balances. So that's all in there. But what I want to show you here is, as your developers, so I'd like to show you the developer tab. So here there's something called as extrinsics. So extrinsics are something that these are the transactions that you send to the chain as an external user or using an external account. So you can see all this core functionality here, right? So here, what I'm showing you is called a pallet. So a pallet is like as Sean calls it, it's like a smart contract on steroids. So basically, rather than writing a smart contract, it being executed in an EVM, where every instruction checks whether it has gas fee or not, whatever core logic you have in here, so let me go to balances and then maybe transfer, which is what you saw. So this transaction has already been benchmarked. So Polkadot SDK has like a benchmarking software. So it checks what is the worst case runtime of this particular function. And then, it gives that weight and to this transaction. And when executing this in the WebAssembly virtual machine, it won't even check for gas fee because it has been prepaid. So you already know how much worst computation you can have. So it'll execute this transaction. Probably it's lesser than the worst case scenario. And it can refund the extra fee back to you, right? So this is much more like elegant design. Again, this ties into how and why like Polkadot is able to offer such scaling and efficient solutions for large volume applications like social media, million airdrops of NFTs or whatever. So the beauty of this is, so this is the developer console, right? So I'm exploring Polkadot. So let's go to some of its parachains. Let me go a little bit. So I used to live in Vermont. Like I actually taught computer science courses there. They are very much into sustainability, and so is Switzerland, where my new home is. So BitGreen is all about like carbon credits. So you'll see probably something about right there. So here they have developed something called as carbon credits palette, where they're putting some carbon credits related information on chain or whatever. But what I'm trying to say is, so all of this you're able to do using like Polkadot SDK stack. It's not a smart contract, but it's a smart contract beyond a smart contract. So these are very efficient blockchain transaction functions that you can develop with Polkadot SDK. If you know Rust, if you know how to read the Rust code in Polkadot SDK, you're able to build these functions right there. So, and you can look at like other chains too, right? So we have probably Moonbeam. This came up in the conversations a couple of times earlier. So if you go to Moonbeam, So they are like a DeFi chain. So obviously they'll have palettes which are very like DeFi oriented, right? So there's assets, there is Ethereum, because they are also like Ethereum EVM compatible. Yeah, so you get the idea. So you're building like a rollup or a parachain in Polkadot. You have a bunch of palettes that are given to you, like battle-tested smart contracts. You can think of it. They are available to you, and then you're able to build like your own custom logic to implement the application that you want. We'll come back again, like after I've introduced you multiple tools, but this should give an idea of how we are doing things here. And yeah, this is the moment I think I should show you this as well. So this is the latest fully supported API. It's called Polkadot API. So I would suggest like using this one instead of like Polkadot.js. All right, so let's go here again. Fine. So, okay, so I hope that gave you a context of why Polkadot. So now let's see how to develop on Polkadot, right? So there's a lot of ground that you can cover as a developer. So you have, if you're a web developer, mobile developer, or desktop developer, there are libraries for you to get started. So what you're going to do here is develop applications that interact with either contracts or runtime or core or even like tooling. So that's one option. And then here, so I told you runtime, which is made of like the palettes. So it's sort of superior to plain smart contracts. Okay, so you can do either. It's okay if you just know like Solidity, and if you want to do smart contracts, that's totally fine. But if you want to venture a little bit further, I have tutorials for you for runtime as well. And then core is like you're actually working on the core Polkadot protocol, which allows for these multiple parachains to talk to each other. It's also an interesting area to focus on, but without like much exposure, I would say you need not look into it right now at this moment. But if you are interested, you can attend one of the Polkadot blockchain academies. So this time around, it's in Switzerland. So there you're going to see like how that development looks like. All right, so I will also post this presentation later. So this is by Sean Tabrizi. He's like one of the best educators of the ecosystem. So my talk, because we have a time constraint, I've shortened it a little bit. But if you want like a full presentation, download those slides. I also included his actual talk in Sub-Zero Reset, like that happened in Bangkok last year. It's 1 hour, but probably you'll have information in there for 2 hours because he speaks a lot faster. So you might want to slow it down a little bit and then listen to what he has to say. Yeah, that should give you like a very good starting point for your project for the next few days. So if you're a web developer, yes, of course, my recommendation is that you go with Polkadot API, PAPI. But if you're already good with Rust and then you want to explore building like web applications, SubXT is the repository you should go to. I actually developed a web app in like a couple of days. So I told you I'm a researcher, not a developer. If I'm able to do it, you should be able to do it as well. And yeah, so the Polkadot.js API right there. Yeah, so there are already some tutorials for you to get started. So I would recommend this. So .code School, again, is by a community member who has started this initiative. So there you have like an intro course to PAPI. Take a look at it and get a feel of how to develop stuff. And also last month, we had somebody who made this more accessible. So now you can actually deploy a dApp in like 5 minutes. So try this as well. So I linked the GitHub repository for that. And see different moving parts. What do I need to know here? Okay, I have Polkadot API. What else do I need to build like a successful web application? So try this out. Like it says, start building a dApp on Polkadot in less than 5 minutes. And if you are unable to, you know which Twitter handle to, attack. So the other thing is subXT. I mentioned to you, right? So if you're like a Rust developer and you want to do more, interact with chains and then create like applications, you should be able to do this. I can show you the application that I have developed. So this is something I made in like a couple of days. So this is for, why isn't it working? Yeah. So basically, okay, I hate the live tutorials examples or whatever. So anyway, so once this loads, it looks like this. So this was purely developed using like Rust and the WebAssembly. So basically, I showed someone earlier, like, WebAssembly, which runs the core blockchain code of all Polkadot chains, is so versatile. You can run it on a browser as well. So I was looking at Wasm calculator. So there are plenty of like repositories. It wasn't just like Polkadot. There are Google's and Facebook's and a lot of other people have worked on this technology. So basically, I don't know why the internet is so slow. But yeah, so if you open something like this, so this calculator, it's running on WebAssembly virtual machine on the browser. So this could also be the blockchain logic. This could also be a light client. Whatever lightweight application that you can create, you're able to run it here. So just to give you a context, like I'll also show you the runtimes of like Polkadot. So if you're building a chain on Polkadot using the Polkadot stack, so basically the runtime is basically a WebAssembly blob, right? So let me go further. So you can see Polkadot runtime is around 1.7 MB, 1.7 megabyte. So that includes the logic for its governance, that includes the logic for validating the parachains or whatever, all working in conjunction with the Polkadot node. So this 1.78 MB WASM file is being currently voted on. So if you go to like Polkadot governance, so let me go to Polkadot chain, governance referendum. Yeah, so this is the one of the referendums is trying to set the code right there. So the hash of the code that we're trying to set should match with the hash of the WASM file right here. So the Blake2 hash you have here. So people know for sure what is being uploaded to the chain is actually the code that is being currently like voted on. So once the Polkadot community decides like these changes are significant and they are in the interest of the network, the upgrade happens. So when the upgrade happens, what happens is let me go back to the So basically, this cartridge, which was 1.3.0, will be replaced by 1.4. Okay, so that's how flexible the network is. That's how decentralized the network is with its governance. Yeah, so this way, like the Polkadot nodes, they need not even update their software. So because the code is uploaded to the chain, to the blockchain, it gets automatically swapped, and there's no hard fork needed for the network. Let's go a little bit even further. Yeah, so if you look at other things that you can do with subXT, you can also create like nice CLI and automation tools. Even this is important for the ecosystem, not just like normal tools. Like we want to make the developer's life easy. So if you want to explore that, you can do that as well. If you want to make, so today or tomorrow when you're trying to do something with like Polkadot tools and this is shit, you want to change it, so you have like an option right there. And I should have taken this presentation like earlier, so that maybe while you ideate, you already had access to this website. So build-on is again like by the same community member who created .code School. So you can check that. It has a collection of like ideas that that can be built using like Polkadot technology stack. So if you still don't have an idea, this is where you should be looking at. Okay, so contract development. So again, Polkadot doesn't have smart contracts. So it was by design. Like, it's not like we couldn't. Of course, the person who developed Solidity and EVM was the founder of like Polkadot too. He could have put smart contracts right from the day one, block one. But the decision was to give like parachains the opportunity to have like thriving like smart contracts ecosystem. And Polkadot being like the base layer that secures and provides like interoperability to them. So we are 3 years down the line, like as a chain. And now the ecosystem is at a juncture where we want to do smart contracts and we want to do it the best way, that is out there. So we want to make sure a smart contract developer also has like the best like developer experience and has access to a very efficient design. And the way we are doing it is replacing the EVM altogether. So if you think of it, EVM, the virtual machine, the way it works, it hasn't changed since 2016. So there was no innovation in terms of like the underlying virtual machine that runs the smart contracts. So Polkadot is actually sort of revolutionizing that space with PVM. So it runs with RISC-V architecture. And I'll show you some numbers that will sort of maybe convince you. So right now, the execution time of like smart contract code, like you can see clear improvements when you just deploy it on PVM. All you need to do is you have a Solidity project. Instead of compiling it to EVM, you just use the compile it to like Polkadot and then sort of deploy it and see clear improvements with your smart contract application. And the improvements shown with the empirical data performance results, so every Ethereum block has a gas limit, right? So let's say in a certain block you can do so and so amount of like computation. So with PVM and Jam, which uses PVM, with that architecture, so if there is like 1.25 EVM gas per microsecond, so with PVM and Jam architecture, you're getting 0.15 to 1.5 million. So there's a million time improvement in terms of like the computational power. So it's no small thing, right? So as a smart contract developer, you're able to have the same code that you have, same application. You just deploy it on Polkadot and have 1,000 or 10,000 fold improvement in terms of performance and improvement with like user experience too. But of course, it may be like a little bit inflated. As a researcher, I don't like buy into projections or like hype. So once we get there, we'll see it. But definitely, we're spending a lot of energy and time and money to sort of bring this to the Web3 and blockchain ecosystem, because we feel, yes, so we didn't venture into smart contracts, but if we are venturing into smart contracts, we want to be the best, right? So the first working implementation of this can be tested out on a production network like Kusama in April. So yeah, I would encourage you to, if you're a smart contract developer, check out like how your smart contract is performing on Polkadot. But so like I said, you can't deploy smart contracts on Polkadot per se, but you're able to deploy it on other chains like Moonbeam, Astar. So feel free to explore the tools that Polkadot SDK has in terms of like Solidity or Rust-based smart contracts. And yeah, so if you're like a Rust developer and then you're like, I don't want to venture into Solidity, but I want to explore creating smart contracts using Rust, then use like Ink. And runtime development, I mentioned to you. So runtime is like smart contracts with a lot more like design improvements, right? So and even in the morning session, like Luca mentioned the same. So he showed you exactly what a palette looks like. It has storage items, it has errors, it has like functions, it has hooks. Like you can actually say, okay, so at the beginning of the block production, I want to fetch some values. Okay, so you can get that through hooks. You can register like events. So all of that is provided to you as a developer using like this runtime development. So if you want to explore further, so look into like Frame. So Frame, again, it can be found in the Polkadot SDK repo. So this is the giant Polkadot SDK repo. So it has a lot of like subfolders. So don't get overwhelmed. So a lot of like Polkadot node software logic is in here. So Substrate is the blockchain building framework through which like a lot of Polkadot chains are built. In here you have like Frame. So it stands for like framework of runtime aggregated modules or whatever. So that is Frame. And then you can see a lot of these folders correspond to a palette. So if you were to implement like staking, you don't have to start from scratch. You can just, use this as your, there's a staking palette right there. So it's like a plug and play. So as a Lego block, you can bring it into your runtime and then make use of it, right? So all of this is there. And then we have plenty of templates for you to get started with, like minimal number of like palettes. So you can explore that as well. Yeah, and then if you're a Rust developer and you want to understand what extra skills you need to have to develop these Frame palettes or sort of create like your own palette, this is the tutorial you would want to like look at. So again, it was Sean's like content. So yeah, so it's called Rust State Machine. So it starts with a very basic premise of like implementing like a state machine. And there's also Substrate kitties. Like again, it's like crypto kitties, but using Substrate and like Frame. And if you're already familiar with Frame, and then if you want to like explore a little bit further, try to understand what's new, I would recommend this talk by Kian. So it was given in Sub-Zero Reset, which was organized by Web3 as well. And finally, so this was my talk in Sub-Zero Reset. It's like launching your own parachain. So if in 5 days you want to launch your own parachain, you should be able to do it by looking at the instructions right there. So I've launched a chain in 3 hours. So it's not a big thing. Like we have like plenty of templates. I can also show you one of the chains that I've launched right now. Where is this? Okay. So we've actually launched a chain to educate people to launch chains. So we call it like Web3 Edu Chain. So the task is to, so if I launch my own rollup and make it like sort of this super chain with all the features and make it available for you to like testing, and Polkadot sort of gives me that opportunity. So we took it. So we launched it on a testnet called Paseo. So let me click on that. And here I'll show the agile core time, the flexibility in action. So right now you see the last block was produced in 3 hours. So let's say your application need not like run 24/7. And so let me go and then produce a block live in front of you. So for that, I need like my parachain like ID. So I'm going to fetch that from a chat box. Just a sec. Okay. Yeah, so this is what I have to deal with working in Polkadot, right? So there's so many. All right, let's do this. So it was launched by one of my colleague. He is the biggest whale of that chain. So I don't have any tokens right now. But let me fetch the parachain ID. Okay, so it's 4518. So the way it works is I go to Paseo network, which is like the relay chain. That is sort of enabling me as a rollup or a parachain to sort of produce a block. So I'm going to go there, go to Paseo network. Developer extrinsics. Okay, so here I'm producing a block on demand. So basically the palette is also, intuitively named on demand. So here Yeah, I don't like this naming a lot. So place order allow death. So what it's meaning is, should the account that is producing or paying for this fees die or stay alive, which is irrelevant. So let me give it some tokens. By the way, these are like planks. These are that like sats for like BTC. So don't be overwhelmed with that number. So I'm 4518. All right, so I'm gonna pay for this transaction. Perfect. So what this is doing is it's telling like the Passio, which is like Polkadot, hey, the parachain 4518 wants to produce a block, and I'm paying you some fee. Let it produce a block. So let's see what happened right there. Okay, so you can see a new block was produced, like block number 35. It was produced like yeah. So this is showing you like how flexible like Polkadot is. You know how many functionalities it is opening up for like rollups. I could also go a little bit further and integrate this chain with the asset hub on like Passio, all through like the XCM in there. So all of those instructions I've given all of them in detail in this tutorial. So you'll be able to launch your own chain. You'll be able to integrate it with like other chains on Polkadot. Yeah, so the opportunities are endless. Yeah, so basically, what does it take from going from a parachain template to like an actual parachain on Polkadot? Yeah, we have core time marketplaces like where you can actually buy the block space from others as well. And this is probably like the limiting factor, right? So 3,500 DOT is a lot. So that is the amount of DOT you need to register your code as a parachain on Polkadot. So it was like about 1,000 KSM like till last week. Just like last week, we managed to bring it down to allow like developers like you to develop. So 110 KSM, it's still high, but still it's accessible, I would say, than 1,000 KSM. Okay, so there are templates, even like Open Zeppelin, we partnered with them. So we made available some EVM templates as well as like runtime templates for you to work with. Yeah, this is not that much relevant unless like you're interested. So basically, to launch a chain, you need a genesis. So this is where you say, hey, I'll have like 1,000,000 tokens, or this chain will have like governance. So all that info is in the genesis. And then the WASM is like where the core logic of your parachain is, all the palettes, all the how it should be working. You just need those two files. And you're basically registering them on like the relay chain. Like, if you're launching on Polkadot, you'll say, hey, this is my genesis, this is my code. From now on, take care of the transactions that are happening on my network. And yeah, so that's what happens here. So every parachain has actually registered its like code as well as genesis. And from then on, its transactions are being like validated by like the Polkadot validators. Yeah, this is something for your information. If you're more interested, like check how a parachain sort of shares its info. Like if you're familiar with like Merkle trees, you don't have to send the whole Merkle tree of the state. So in each block, there will be some transition. So let's say one account sends the other like 50 tokens. Something happened in democracy. So only those nodes have changed. The hashes of the rest of the network are the same. So you don't have to send every info there. So here we are achieving some form of like efficiency as well. And yeah, so if you launch a parachain and if you're looking at like cross-chain compatibility and then testing, so here is the tooling that you want to look at. And we're almost at the end of the presentation. I think it's just a couple more slides. So if you're like someone who's using Polkadot SDK and you're having some issues or you have some wish list, you're able to add them here. As users, you're able to have that wish list right there. And there are Polkadot developer bounties. So I'm showing you avenues where you could get funding for your effort in this 1 week. Let's say you build some app, you're trying to take it like even further and get more funding. We have opportunities for you. So there's Polkadot open source stack. So you need not build everything from scratch. So if you go to this particular link on the wiki, yeah, so you have so many categories, right? So let's say we go to wallets. So here you have all the GitHub repositories with like open source code that you can fork and use in your projects. So basically, it's a huge repository. So we've funded all of this using like the grants program or like the treasury. So make sure that you're aware that they exist and you don't have to start everything from like scratch. Yeah, and then if you want to look at the previously accepted like grant applications and see, hey, this should not have been funded, or I could do this, I could get funding for this, feel free to look at like all those descriptions. So none of this is like behind the closed doors. Everything is like open on the GitHub repository of the grants team. You can look at the reviews. You can check, why it was rejected, why it was accepted. All of that info is there, and that's something for you to explore as well. And it doesn't end there. Like Polkadot is also the biggest DAO out there with a huge treasury. So Polkadot has about 29 million DOT to facilitate like developers like you, and a lot more other initiatives as well. So, and it also keeps the assets in stable coins, not just like DOT. So you can also request for funding in DOT stables. So if you think like DOT token is too volatile. And there are like resources for you to, there are resources that help you to submit a referendum if you'd like to. And yes, I know most of you also want to like learn about like Polkadot or Web3 in general. So we have a lot of like education initiatives. We also want to make entrepreneurs out of like students. So check out our courses. Like there are also lots of flyers about like PBAX. So we launched that course in January. It was a success, like 580 people registered and 360 people finished it. So we also have some PBAX graduates here, including Jay right there. So yeah, I don't know if you want to recommend that, but yeah. So I think we did a decent job like putting together, giving you a broader vision of like what Web3 is. We shill Polkadot at the end, but we save the first 4 modules for like general concepts. Yeah, so that's the course that I'm talking about. So it's foundational and it's for everyone, especially for developers. If you want to understand like why, Web3 matters or, what's exciting about it, I think this course sort of delivers. And I told you Polkadot is also very decentralized, not only in the technology stack, but also as a developer, you could get salary like every month or every couple of weeks from Polkadot Treasury if you're contributing to the fellowship. So as a fellowship member, rank 1 member earns about $10,000 in a year. Rank 4 and above, I think it's $120,000 or even $200,000 a year. So on par with like OPEC salaries out there. And this is possible if you take a look at like Polkadot SDK, and then there are lots of open issues. You start contributing as a core developer. That gives you a path for the core fellowship. And finally, if you liked what you saw and then you want to see like Polkadot scaling to like even like billions, then we have that as well. So we're not stopping with this sharded multi-chain architecture. We're also looking at something even further. Right now, Gav is in a jam tour. So he has toured India. I was there like a couple of weeks ago, or last week. I lost track of time. So I was there in India, and now he's in like China. But yeah, so we have something coming for you after you built a smart contract that works like fantastic on Polkadot. If you want to go a little bit further and then, run it as a service, you should be able to do it on Jam. And yeah, so I think I was able to give you some info that could help you with your 1 week hackathon here. So I'm available for most of the time in the mansion. I'll try to spend my time here and do work here. So if you have any questions, either shoot an email or see me in person in the mansion. Thank you. I can also take questions now.
With the box.
Thank you. Yeah, so I think this question is just because I don't have the strongest understanding of rollups, but in the beginning of the slide deck, you were talking about how a limitation is of rollups being able to talk to each other compared to Polkadot's parachain communication. So I guess my two questions are the relationship between rollups and parachains and how they work together, and then kind of the differences in them.
Sure. So if you looked at like Ethereum, like when it was launched, it never assumed that there will be rollups on top of it.
Okay.
It was supposed to be the world computer. Everybody was supposed to use it. And then there were like scaling issues. And then rollups were built to address that scaling issue. But meanwhile, like, Polkadot already started its like white paper and then design keeping the scaling issue in mind. Like they were like, okay, so there will be scaling issue on Ethereum. How do we solve it? So they went like ground up. There's something about like Ethereum that it took like a weekend to sort of make a proof of concept, and it took like a couple of years to create the sharded design of Polkadot. So that's the level of complexity we're talking about to enable a sharded architecture with like blockchains like sort of running on top of like another blockchain and then being able to talk to each other in a secure manner, which is part of like the core protocol. It's not like something that is built as like a patch. So
Yeah, so I guess do you have like a concrete example of parachains talking to each other? Like, I guess why would that be useful from like a user perspective?
yeah, sure. That's a very good question. So let's say I have an asset on one parachain and I want to send it to other parachain.
Gotcha. Yeah.
So now, if I'm not having the shared security of like Polkadot, I could be hacked or they could be hacked So by making this transaction secured by like Polkadot, you're not giving anybody that chance. So
I see.
to attack your transaction, they have to attack the whole Polkadot network.
That makes sense. Yeah. Thank you.
Yep. Any other question? Yeah.
Do you wanna?
For the recording.
Yeah.
So, are there any account abstraction frameworks? I was looking briefly into it, but I couldn't find anything.
Yeah, because even account abstraction was part of like the core protocol, so we didn't name it like account abstraction. So basically, you can set proxies to do work. Like you can set a governance proxy, you can set a staking proxy. There's also
So just to make it more clear what I mean, basically the wallets, for me, the Polkadot wallets are, even the Ethereum ones, if I exclude Rabbi, are not good enough user experience. So now what is prevailing in the Ethereum world is basically, they call it, there are different names, but let's call it account abstraction. Basically allowing a user clicking stuff somewhere on the browser and in the background stuff happening on the browser, on the blockchain, without having this pop-up of these ugly wallets, That's what I mean, basically.
Yeah, that's what we need right now in the ecosystem. So like I said, we sort of created the backbone structure, and I see a lot of UX people here. They have to come up with solutions like that for, making it like easy for the user to. It's mostly like front end. There's nothing like back end that is stopping you from implementing it.
Okay. So is this the framework that we're supposed to
No, I'm
use?
just showing you something like so we have a bunch of multi-sig wallets in the ecosystem. So I think this is the enterprise one. Could basically Yeah, so this is like, it looks like safe as well. So basically it's like a multi-sig with all these people. We sort of like, yeah, at the end of the day, like, this is connecting to like a wallet, extension. So it fetched my details, I signed it, and then now I'm able to make like transactions in a multi-sig. And even, so like I mentioned about proxies, right? So this is capable of implementing those proxies as well. So if I go here and then maybe, let's look at the, yeah, so basically you create a multisig, and also if you have a proxy, this links to another account where you can swap out this and then sort of give it direct connection. Anyway, so I'm going into too much specifics, but for your answer, we don't have such UX in the ecosystem yet. But there's no reason why we shouldn't have it either. I think people really have to understand how the backbone works and then try to create the UX on top of it.
I mean, doesn't Mythical basically have built that out on the UI?
What's that?
Mythical has already built that out on their UI.
Mythical?
Yeah.
Yeah. So again, like, so I'm also aware of like Amplica access. So this is by Frequency guys. So the way it works is you just need like a mobile number or like email, and then you should be able to have like a blockchain account that you can get self-custody if you wanted to. Else you can just like bank on them to do your stuff. And the way it works is, so I told you here. So basically with account abstraction, features of like Polkadot, you can set a proxy account, which will be here. And this can be entirely swapped out, and then you can control that account which doesn't have a private key. So that way you can give self-custody of a blockchain account to someone else because you never expose the private key of that account. So yeah, we have features like this, and that requires understanding and people really getting the point and then being able to build like the UI and UX for that.
Yeah, so earlier in the presentation, there was a mention of trustless bridges. I wasn't too familiar with that or kind of what that meant.
Yeah, so usually if you want to send Bitcoin to Ethereum, so the way it works is right now I think there is, wrapped BTC, like WBTC. So let's see what they say. So what they do is, so they have like a protocol where, every Bitcoin, it's in a custody of like someone. Like on Bitcoin, there's not even scope for implementing smart contracts. So basically, if they see a Bitcoin there, they're going to mint a corresponding WBTC here.
Yeah.
And in between, it's either a human, or it's a multisig, or it's a DAO, or there's a middleman for sure in between giving that info. Okay, so mint it there, mint it here. So instead, if two protocols could understand each other, you're closely monitoring like Bitcoin chain, and by you I mean the consensus, the protocol, the core protocol itself is able to understand what's happening on Bitcoin, then you don't need a middleman to do it. So basically, you're looking at the block explorer of like Bitcoin directly. The protocol itself is looking at it, and then once it sees the asset on a specific account, it mints the derivative token on the other side.
So in that traditional example you gave, where is the human interference? Like, for example, sending like Bitcoin to Ethereum, like that minting and the locking process. Like, I guess, where's that human interference that a trustless bridge would remove?
Yeah, so I think giving Ethereum example would be much better. So on Ethereum, we have like a smart contract that was deployed by Snowfork. Like they even launched this like chain which sort of enables like trustless transfer of like assets. So the way it works is the smart contract on Ethereum, it understands like what's happening on Polkadot. So it's looking at the chain's like latest block headers and then looking at whether a specific state is like valid. So Ethereum side understands what's happening on Polkadot. Polkadot protocol itself is running like a light client of Ethereum. So you can actually see that on the Bridge Hub. So if you go to Polkadot, like Bridge Hub, so in this, like there should be a palette. You know, if you go to extrinsics, so here there should be, So there's like Ethereum client palette there. So its job is to check like whether things have happened on Ethereum side. Yeah. So here there's no multisig or middleman or anything. So if at all there is a middleman, it's the entire Polkadot validator set because they are the ones who are enabling this communication to happen.
Gotcha. Thank you.
Yeah. Yeah.
Is there a resource that can maybe help someone like me use Polkadot.js better? Because at the moment, when I access it, I'm clicking on different chains, trying to understand like the palettes. And I don't even, then I even forget what it is I'm looking for because there's just so much.
It's not just you. I can say that. Yeah.
So is there, I don't even know what I'm looking for at this point, like something to help me go through it, I guess.
Yeah, that's the reason I said like, Polkadot.js, it's not for everybody. So yes, it has so many features, but sometimes being minimalistic also helps, right? So for like a newbie. So I think, Papi, so dev.papi.how/explorer, I think this works better in that case. You're able to, get like so this is sort of a minimalistic like version. So I can zoom in a little bit.
Okay, yeah.
It's dev.papi.how. I think the link is also there in my slide deck.
Yeah.
So the beauty of like Polkadot chains is that, you just need to plug in the endpoint, like, the blockchain networks like endpoint, and then it generates the documentation. It generates like everything for you. For instance, like subxt explorer. Let me show that to you. So if you're like a Rust developer and then so all you need to do is like you put like the chain endpoint right there, and then you click on generate docs, and it creates like documentation for you out of the chain's metadata. So it also gives you, hey, I want to interact with like a balances palette.
Right.
So what kind of calls that I need to create? So it gives you like sample code that you can just plug it in, and then it sort of works that way, right? So we want to, even with like Papi, we want to have such documentation, ready for you, so that you just copy it and then you plug it into your code, and then you're able to interact with the blockchain network that way.
Okay. Thanks.
But yes, I don't have like a answer there, but understanding like how like the Polkadot SDK chains like work and how they expose the metadata for you, that sort of lets you go to the places where you should be looking for.
Right.
So here, for instance, if you're looking at like, what kind of storage does this like palette have, then you can take a look at it. So here, total issuance, it's like a U128, meaning it's like a 128-bit variable, right? So it's all. So once you explore it, and then you can generalize it to any Polkadot SDK chain.
Okay, I'll take a look.
Okay, I think so I'm here, so feel free to ask me questions in person too. Thank you.